Hello and welcome techies. I am Sambhav here. This is the third part of data type. In the previous videos we have already discussed about what is data type, what is the significance of data type. We have seen a high level overview of different forms of data types available in Postgresql. In detail we have also discussed about Boolean data type and integer data type. In case you have not watched my previous videos on SQL, please go ahead and check them out. I will attach the link in the description for you. In today's session, we are going to talk about the following: the general data types in PostgreSQL. We will just review them, and then we will go into number data type. And inside number data type, we are going to discuss about floating point numbers, arbitrary precision numbers, and serial data type in detail. So we have already seen the general data type in PostgreSQL: Boolean, numeric, character, datetime, UUID, JSON, arrays, edge stores, network address, enumerated. In the previous video, we have discussed about the Boolean data type in detail. We have already discussed partial numeric data type, which is the integer part. Today we are going to complete the numeric data type, where we will talk about the floating point numbers, arbitrary data types, and the serial data type. In upcoming videos, we'll talk about character, datetime, and rest of the data types. So in the previous video also, we have seen the numeric data types can be mainly categorized into four types: integer, floating point types, arbitrary precision numbers, and serial types. And we have already seen that integer data type and serial data types, they both denote the same. I mean, integer data type, broadly categorizing, if you're broadly categorizing your numbers into two types, which is decimal and integer, then integer and serial data types points to the integer type, and floating point types and arbitrary precisions, they boil down to decimal data types, right? We have seen all these data types in detail in our last section, and we have also done a lot of practicals for them. In case you have any questions, please feel free to post your questions in the comment section. In today's session, we are going to mostly talk about floating point numbers in detail. So in floating point numbers, there are mainly four data types. One is decimal, one is real, also called as float 8, double precisions, and float n. So let me come over here and let me explain it to you what this data type is all about. So decimal data types, the storage size is variable. That means we do not have a fixed storage size. As and when the value is inserted in the decimal data type, the size varies, right? And when it talks about the range of decimal data type, it is up to 13107 two digits before the decimal point, and up to 16383 digits after the decimal points. What I'm trying to say here is, let's assume that we have a number, a decimal number. So if I say here this is a decimal point, and before the decimal point I may have some numbers, let's say 1, 2, 3, 4, and after the decimal points I might have some numbers 6, 7, 6, 8, and so on and so forth. So what it says is we can have 13107 digits before the decimal, right? And we can have 16383 digits after the decimal. This is applicable for decimal data type. This is applicable for decimal data type. Talking about the next data type, which is real, also called as float, it has a fixed storage size of 4 bytes. It has a fixed storage size of 4 bytes. We are also saying it is inexact. We will talk about inexactness in detail. What is the meaning of all these things in detail? It has a variable precision, and it can accommodate, it can have maximum 6 digits after the decimal point. So when we talk about real data type, also called as float data type, So after the decimal, so suppose this is a number, let's say anything x or y. After the decimal, it can maximum have 6 digits. It can have maximum 6 digits. Next one is your double precision. So double precision is, you can say, a higher storage format of the real or float itself, as the storage size increases from 4 bytes to 8 bytes in double precision. And the difference is that, another difference is that it can store 15 decimal digits after the precision. So when we are talking about the double, when we are talking about the double precision data type, right, double precision data type, after the digit, after the decimal, it can accommodate up to 15 digits. It can accommodate up to 15 digits. That's the major difference between real and double precision. Real is also called as float. So one of the interview question which you might face is, what is the difference between real and double precision, or float 8 and double precision? So in terms of storage, the type of value they store is same. They store decimal numbers, but the difference is only in terms of storage size. So real or float 8 stores up to 8 bytes, whereas double precision stores up to 8 bytes. And if you're talking in terms of precision value, that is number of digits after the decimal, then real stores only 6 digits after the decimal, whereas double precision will store 15 digits after the decimal. Then comes float n. Float n stores up to 8 bytes, and it is again variable precision with inexactness, and accept precision up to n bits. So you must be very mindful that this n is not the number of digits, but this is number of bits. You have to be careful about this. This n does not denote the number of digits. This n denotes the number of bits. Maximum 53 bits, max of 8 bytes. I will explain all these things in our example, right? Now, you might have noticed in real, in double precision, and in float, I have used the word inexact. Inexact. What is the meaning of this? What is the meaning of this double precision? Inexactness. So inexactness basically means that some values cannot be converted exactly in the internal format and are stored as approximation. What is the meaning of it? Let us understand. Let me just clear this up so that we can understand. So suppose I am having some value. Let's say I am having some value. Let's say 476.13121765. Assume this is, I'm just taking an example. So assume that I'm having a value like this, right? And which I'm trying to store it in my table. But there are chances that when you retrieve this value, there is a possibility that you may not get the exact value as you store. The reason, what you might get is an approximation. What you might retrieve is approximate value. Why approximate value? Because both real and double precision, they have a limitation with the number of digits they can store after the decimal. So for example, let's say if I'm trying to store a result, I'm trying to store a value in a field or a column which is defined as real or float, which can only accept 6 digits after the decimal. So but you see here there are a number of digits: 1, 2, 3, 4, 5, 6, 7, 8, 9. It means it has 9 digits. So it will not be able to store all these 9 digits. It has to restrict its storage only up to 6 digits. So it will store this value as an approximation. It will approximate this value and store it, right? It may not be able to store in the exact form. Same thing applies for double precision also, because sometimes when you are inserting the values, you might have a limitation. You definitely have a limitations, right? 15 digits after the decimal. But if you have more digits after that, it means that value which you are trying to store with number of digits more than 15 after the decimal, then that value will be stored as approximation. We will see in detail in our upcoming practicals how this approximation is being calculated by SQL. Same thing applies for float n as well. So this also stores the value as approximation. Now, when these values are stored as approximations, right, there could be two possible problems. One is storing the values. Sometimes it also, shows some problem at the time of sorting. When you see the sorting values, you might see small discrepancies whenever you are sorting or you are even retrieving the values. There could be slight discrepancies because the values are not stored as exact values but as an approximation, right? Now, then you might ask me, since this is storing it as an inexact, these are inexact values, or you can say these are more of approximated values which is being stored. But in case if you really need to store the value as exact values, then what should you do? For that, SQL has provided you a solution to use numeric type. We will talk about the numeric type in detail later. Now, another thing which you might come across, sometimes you might come across this problem is comparing two floating point values for equality. Now, suppose you might have inserted the value something of this sort. Let's say, for example, 412.76112345. Assume, and this is a real data type. Assume I am saying this is a real data type. Now, suppose how many digits are there? 1, 2, 3, 4, 5, 6. So float will restrict and store only this much. These two values will not be stored, right? Now, suppose you are comparing, let's say this value is nothing but, assume, amount column. This is an amount column, right? Now, when you are performing any comparison, let's say, for example, where amount is equal to, assume you are saying where amount is equal to this exact value, when you give like 3, 4, 5, you may not get the desired result. So you should be mindful about that also. That's what I was trying to mention here. Comparing two floating point values for equality might not always work as expected. The main reason is because they are being stored as approximation. Now let's jump into some practical example to understand all these data types. So I have already created few of the columns, a few of the table for us. So I'm creating a floating point number. So let's see, we are creating a table here called as float table, in which we have defined all the possible data types, right? So we have a column called as amount decimal, then we have a column called as amount real, amount double, and amount float. And for each of the column, I have defined different data types. So for amount decimal, the data type is decimal. So I just use the name decimal so that we know that it is a decimal data type. Amount real is of a real data type. Amount double is of double precision data type. And then I have used float n. Here n, the value of n is 3, and 3 denotes the number of bits, not the number of characters. I have already explained you. Here float n indicates the n is the bits, right? Not the number of digits. Now let me execute this piece of query to look at our result. Our table has got created. So let me refresh my table, and you see I have got a table called as float table. Now let me execute this. Now we know that we will only get the column, we will not get the values because we have not inserted any values. Now let us try to understand this entire data type with few cases. First case is inserting all correct value for the columns. Means I am inserting right value based on defined size and limit and range, everything. I am storing all correct values, right? So the first value is for amount decimal, which is of numeric. Now, one more important thing, very good, this has come up over here. Now you might see that amount decimal, while creating the table, we have created it as a decimal, but this has been created as a numeric data type. You should be mindful whenever you are trying to create any table with a decimal data type, automatically SQL engine will internally convert into numeric data type. It will automatically convert into numeric data type. Now we will talk about the numeric data type and its characteristics in the upcoming session, but let us dive deep into it. Now the next column is amount real. So you see the data type defined is real. Then we have amount double, which is nothing but a double precision. And then we have a float 3, which is mentioned here as real again. Now again, this float is again being converted. If you notice here, this float is being converted to real. Now I will talk about this conversion. How does SQL actually decides to convert this float to real or to any other data type? Always remember, SQL will never store this as a float. Whenever you are defining a column with float, SQL will never store them as a float. Rather than that, SQL will convert it into real data type, or sometimes it might also convert the float to double precision. I will talk about those scenarios in our upcoming practical session. So for the time being, remember that float is always being converted to real or float a data type. It is also being converted to double or precision. How does that conversion happens? We will talk that in detail, but for the time being, if the float size, that is the n bits, if it can be accommodated, the size or the number of bits which you have defined, if it falls into the range of 4 bytes, then the data type is converted to real. But if the number of bits is higher, let's say around 30, 40, 45 or something, then it will fall in the range of 8 bytes. So internally SQL will convert it into double precision, right? So now you might have got a real idea, a real picture about why this amount decimal has been converted to numeric and the amount float has been converted to real data type, right? Now let us insert some values in our table to see how it looks like. So I am inserting this value. So you would notice that I am inserting all correct values. So for amount decimal, I can insert any number of values. That's what it says, user specific precision. And this is exact because numeric is exact. I have already explained you here that if you want to find a solution where you want to store the value as an exact value, then you should not be using real, double or float. Then you should switch to numeric data type. So definitely this will store as a exact values. Then talking about real, so this we know that it will store up to 4 bytes, real 4 bytes, that is 6 digits after the decimal. So I am keeping that to few. Then again for double precision, and then for float, which we have defined it as 3. Now let me execute this piece of query and let's see what happens. Right now, let me look at the table. Let me fetch the data from the table. So you see the value has been inserted. So whatever value I have inserted, all the value has been stored exactly in the same way. So for amount decimal, we have given this value, which is internally being converted to numeric. So it stores all the value 1, 2, 3, 4, 5, 6, 7, 8, 9. Whereas for amount real, we know that it can store up to 6 digits after the decimal, but here we have inserted only 1, 2, 3, 4 digits after the decimal, so it has stored well. Double precision can store up to 15 digits after the decimal, so it has stored them very well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then again I have taken 6, so it has stored all the 15 digits very well. And then it is 1, 2, 3 digits after the decimal. Now let us get into another use case. Now this time I'm trying to insert more digits for decimal data type, more digits for more number of decimal digits for real data type. Now we know that in the real data type, the maximum number of values which you can insert is 6. We know that for real or float, the maximum number of digits which you can store after the decimal point is 6. But you would notice here that I am inserting 9 digits. Now what will happen if I execute this? What will happen? Is SQL going to throw error or it is going to store the value? So you see here the SQL has executed the query successfully, and that means the value has been inserted. And now let me execute this and look at my table. Now, when you look at the table, you would see here the value is inserted as 222, and after that, it has not inserted all the 9 values. Rather than that, the value is 1, 2, 3, 4, and 6. Now, let's see what has happened. Let me bring this value to this place. Just let me clear up this board a little bit. Now, when I am saying, let me clear all these things as well. So here, the value which we have inserted is this, right? This is a value which we have inserted. Sorry, this is a value which we were trying to insert, but actually SQL has only inserted 1, 2, 3, 4, 6. Now let us see what is SQL doing here. So we know that this value which we have inserted is for float 8 or real. This is for real data type. This is for real data type. Now real data type says that it can store maximum 6 decimal digits, right? It can store 6 decimal digits. But here we are trying to store 9 decimal digits. So now what SQL is doing it is performing a round off operation. It is performing a round off operation. It is performing a round off operation. What does it mean? So you see here 2, 2, 2. Now 1, 2, 3, 4, right? Now it can store up to 6. That is what the meaning is. So what SQL is trying to do is it is trying to accommodate up to 6, because of which it is rounding off to the previous value. It is trying to accommodate the 6th value. It is trying to accommodate the 6th value, because of which it will round off the previous value. So when we round off the previous value, since 6 is greater than 5, the previous value will be incremented by 1. So we will get here as 6. So the value actually will be stored as 1, 2, 3, 4, and 6. That is what it shows. 1, 2, 3, 4, 6. Right? So you must be very careful that whenever you are trying to insert more number of digits after the decimal for the real, that means beyond 6 digits, then SQL will automatically round it off, right? Let's go to the next scenario. In the next scenario, we are trying to insert more digits after the decimal for the float 3, because you remember we have created this table, and the amount float, we have created it as float 3, right? So now we are going to insert this value. So here you might notice that again I'm going to insert more than 3 digits. In the previous 2 examples I have inserted only 3 digits, but now I'm going to insert more than 3 digits. Now again let me execute this piece of code and let's see what the result is, right? So definitely now we know that the SQL will not throw error for the excessive digits after the decimal. Rather than that, it will round it off. Now you see here it has again rounded off this value 1, 2, 3, 4, 5, 6, 7, 8, 9, which I was trying to insert, but I have defined float 3. Now the moment I define float 3, what is the meaning of it? The moment I define that I want my value to be of type float 3, first of all, whenever you are saying, okay, I want to have a column with, float 3, means this 3 is nothing but a bits, 3 bits. That is what SQL says. It is 3 bits. It is not number of digits. So when you're storing more than 3 bits, it will try to round off. And the value, now the value which we were trying to insert here, you would see is 44.123456789. But what it has done is within 3 bits it is only able to accommodate this value. It is only able to accommodate this value. So here we were trying to insert 444 dot. So let me bring this value over here. So here we were trying to insert 444 dot 1 2 3 4 5 6 7 8 9. Now since in the column we have defined that float can only have 3 digits after 3 bits after the decimal. So it is trying to accommodate this value within 3 bits, and based on that it will round off. So here what it is doing, it is capturing 1, 2, 3, 4, 4. Means till 4 it is good. Till 4, I mean till here it is able to capture. So the value which SQL has captured is 44.12, and then it is 344. 344, right? So this is, again, it has rounded off, and based on that the value has been stored. So that is a reason why these data types are called as that inexactness. They are having a nature of inexactness. That means they are storing the value as an approximation. They are storing the value as an approximation because of the rounding off nature, right? Now let's look at another example. Now what will happen if I try to insert integer value on my decimal columns? So all these columns which are saying amount decimal, amount real, amount double, amount float, they all are defined as decimal data type in one or the other form, numeric or real or double precision or real, whatever it is. But I am trying to insert integer values, right? In the first row of data, you might have noticed that first value, which is numeric, I'm inserting as an integer value, not a decimal. And in the second, for all the rows, for all the columns, I am inserting only the integer value. So let me execute this piece of code and show you the result. Now when you see the table, you will be surprised that they all are stored as integer value. Some of you might have expected that these integer values will be converted as decimal values. So 111.000 or something, 222.00, 333.00 something, in order to represent it as a decimal value, which SQL has not done here, which PostgreSQL has not done here. Now what it is doing here is, it is actually storing this value as decimal itself. It is actually storing this value as decimal itself. The only thing is that it is not showing you the number of digits after the decimal as 000. But in reality, in background, these values are stored as decimal itself. It is not because that here, since the .00 is not appearing, so don't get confused that these are stored as integer values. These are actually stored as decimal values itself, right? Now next thing is, can this decimal values accept null values? Yes, of course it can. Of course it can. So you see, I'm trying to insert null values for the entire row, which it will accept easily. Okay, sorry, my bad. Let me execute this piece of code first, and then let me show you the table. So what I have done here is, I have inserted all the null values, which is reflected here. So you should be very cautious that all of these data types, whether it is a decimal, whether it is real or float 8, whether it is double precision, or whether that this is float n, which is float 3 here, all of them accept null values. There is no problem at all, right? Now here, so this is about the in general talking about all these data types. Now let us create another table to understand the real data type, the real column over here, which is nothing but float. So if we look at our float here, you see float n, and it accepts maximum of 8 bytes, variable precision, inexactness. We know what is the meaning of inexactness now, and accepts precision up to n bits, max 53 bits, max of 8 bytes. Now let me explain you this part clearly, because I know this is a bit confusing. So let's get over here. Now in this example, let me insert, I'm creating a new table called as float table 2. I am again having the same columns as what we had earlier. Only thing is that I'm changing the size of float. Now in spite of 53 bits, let me give 59 bits, assume, in this example. Let me execute this piece of query. 59, you see what is the error? It says the amount float, that is float 59, 53 is the max value. 53 is the max value. That is the meaning of 53 bits. That means whenever you are creating a column with float n, whenever you are creating a column with data type float n, the maximum n value can be only up to 53. Let me try with 54 also once. Let's see if that works. Let me execute this. The moment I execute this, again it will throw the same error that 53 is the maximum value. So let me push 53 over here. Now if I create this table, there won't be any problem. And now let me show you this particular table. Now you will be surprised to see that now the amount float column whose n value is 53 bits, now it has become double precision. In the previous example, when I have defined float 3, let me execute this, you might notice that this amount float table was only real. Remember, I told you that float, whenever you are creating a column with float data type, internally it will get either converted to real or it will get converted to double. If you are defining less number of digits for float n, right, then it will convert to real or float 8. But if you are defining a higher value, right, then it will convert to double precision, right? Another thing is that based on the value, the size, since it is being internally converted to real and internally being converted to double, so the storage size of float also will change. If the float is converted to real, then the maximum storage size will only be 4 bytes. If the float n, if the value is higher, and if it gets converted to double precision, then the storage size will become 8 bytes. You must be very mindful about it. Then you might ask me that, okay, till what number of bits it is real and after to what number of bits it becomes double precision. I will talk about that in detail. Now, since we have created this particular table, let us look into it. So now let me show you the float table 2. So here you see it has created double. Now this is the highest value. You must also remember in PostgreSQL, the highest number of bits which you can assign for float is 53. This is also an interview question. Sometimes it is being asked. So I'm inserting a very simple value, and here you see I'm inserting a lot of digits, right? Now the moment I execute this, I will be able to look into all these data values. My bad. So you can see here all these data values. Let me bring it over here. So you see all the values after the decimal has been accepted. Let me zoom in a little bit. So you see all the digits after the decimal has been brought up, right? Which we were trying to insert, right? I'm sorry, yeah, this is what we have, right? Now, why it is accepting all the values? The reason is very simple. Since we have used a higher value for n, this float has been converted to double precision. The moment it gets converted to double precision, the storage size increases to 8 bytes and the number of digits after the decimal increases up to 15. The number of digits after the decimal increases to 15. That is why you see here all these values are being accepted, right? All these values are being accepted. Now, there are few more important things you must remember. Which you must remember. First, when it talks about float data type, now if you write float 8, that means you are creating a real data type. You are not creating a float n, right? Second, when you define float 53, This is the maximum value. This is the maximum value. But what if I only create float without any precision, without any n number of bits? Is it possible? Is it possible? Let me execute it and show it to you. Definitely it is possible. Now let me execute this table and let's see what is the value. So the moment you do not define float n, automatically the size of the float n is being considered to be as for 8 bytes. 8 bytes. The moment it becomes 8 bytes, you know that it is of the form double precision. It is of the form double precision. Let me show it to you here. So there are few points I have written. Accepts precision up to n bytes, max is 53. If float defined without precision, then it will accept maximum 8 bytes, and hence internally it gets converted to double precision. So you must be mindful about this also. It also accepts integer values, but it accepts integer value, but it stores them as decimal values itself. The meaning is that if you are trying to insert a row with integer value, the PostgreSQL will not throw error. It will accept that, but internally it will store it as a decimal value. And you see, this is a null value. We already have discussed that they accept null values, right? Now, let's talk about one more point here. Let's talk about one more point here. Now, because since we have seen that, you know, float is internally getting converted into, real or double precision. Now, what is the factor? Now, how does it get converted? Let's try to understand. So it is pretty straightforward. If I say here float up to 24, that means if I say the bits, if I define the bit size of 24, then it stays within the limit of 4 bytes. That means then the storage, then the value can be stored with 4 bytes, and hence it gets converted into real, right? But if it is beyond 4 bytes, that means the moment I give float 25, that means more than 24, then the required space to store the value is 8 bytes. The required space to store this value is 8 bytes, and it gets converted to double precision. It gets converted to double precision. So this is the threshold value. That means if float defined from any value from 1 to 24 bits, then it is of real type. Then it is of your real type, right? But if it is beyond 24 like 25, right, then it gets converted to double precision. But the third point which you should remember is the maximum value of this can be n could be 53. We have already discussed maximum 53 bits only you can define, right? So that is the logic behind float being converted to real or double precision, right? Now let's talk about arbitrary precision numbers. Let's talk about arbitrary precision number. Now, before we jump into arbitrary precision number, there are two important terms which you should be aware of. One is called as precision and another one is called as scale. Precision is nothing but it denotes the total number of digits before and after decimal point. Let me explain it to you. So suppose I am trying to write down a number over here. Let's say, for example, I have 1, 2, 3, 5, 6.7, 7 and 7, right? Suppose I am trying to have this number. Now if you look at this number, there are two parts. this is the integer part, that means before the decimal, and this is after the decimal, right? There are two parts of it. When we talk about precision, precision denotes the total number of digits. The precision denotes total number of digits. So what is the total number of digits? Which is nothing but precision. If I say what is a precision, so 1 2 3 4 1 2 3 4 5 6 7 8, that means precision value is 8, right? Precision value is 8. So precision denotes the total number of digits before and after, before plus after the decimal. That is what precision stands for. The next one is scale. Scale only denotes the number of digits, after the decimal, number of digits after the decimal. Always remember, after the decimal. After the decimal. That means in this example, the scale is 3. The scale is 3. The scale value, if you look at this, so here P is 8 and scale is 3. I hope this is clear, right? So precision denotes the number of digits before and after decimal point, whereas scale denotes the total number of digits after the decimal point. Now let's look into our numeric data type, right? Numeric data type. Let me bring this over here. So in numeric data type, these are the different data types, which is like numeric P comma S. P stands for precision, which is nothing but the total number of digits before and after the decimal. That means this is the total number of digits. S defines the scale. Here numeric P, and the third one is numeric. That means if you look at it, it means the first one numeric is, here we are defining both precision and scale value. Here we are defining both precision and scale value. Here we are only defining the precision value, whereas here we are not defining anything. Now what does it mean? So here when we talk about numeric P comma S, again precision and scale, so it clearly states that up to 13107 digits before the decimal point and this many digits after the decimal point. When you only define P, that means precision value and no scale, when you do not define the scale value, which means numeric values without decimal, because I have not defined S here, right? S stands for scale, which is used to indicate the number of digits after the decimal. But since I have not defined S, means it is not going to accept any value or any digit after the decimal. So this is like, you know, it will be like an integer value itself. It will be just like an integer value itself, but it is not storing as an integer value. Definitely it is not storing as an integer value. It is storing as numeric data type, but I was just trying to explain it that it is just like an integer value, because we are not, it will not accept any value after the decimal. Then is numeric. Numeric is like, boss, you can have any number of values of any length which can be stored before decimal, after decimal, everything is fine. Let us try to understand this with example, right? So here I have created a table called as arbitrary table, which has got 3 columns called as cost price, selling price and profit. Cost price, I have defined both precision and scale. That means here the precision value is 10, which means total number of digits including before and after the decimal is going to be 10, and 3 is the number of digits after the decimal. Similarly, selling price is numeric 5, means I have only defined the precision value. That means the total number of digits is going to be 5, but I did not define the scale value. Scale value is nothing but number of digits after the decimal, but here I am not defining it. Means I want this selling price to store only the integer part of the value, not the decimal part, right? Then profit is numeric, where I have not defined anything, numeric or precision. Now let us create this table and have a look at it. So let me execute this. My table got created, and let me look at the data. Now since we know that we have not inserted any values in it, so we are not able to see any rows. Now let us insert some rows into this particular table. Now I am inserting all correct values, all correct values. Now the first one, which is the cost price, which indicates 10 comma 3. 10 is the total number of digits and 3 is the number of digits after the decimal. So I have done the same thing. 7 plus 3, 10 is the precision value and 3 digits. Here 5, I am only inserting the non-decimal values, and this one is numeric, so it can accept everything, so there is no problem. So let me execute this and let me look at my table, right? So you see the value has been inserted the way we wanted, right? The way we wanted. Now let us insert more number of digits after decimal for numeric 10. Now in numeric 10, when I'm saying numeric 10, this is the cost price, means 10 digits as a total, that means before and after, and only 3 digits after the decimal. But you see here I am inserting 6 digits after the decimal. I am inserting 6 digits after the decimal. So what will happen if I execute this query? That means I'm trying to insert the table rows in the table. Now if I execute this, the first thing you should notice here is that it has executed successfully. That means there is no problem. There is no problem at all. Even though you have defined the scale value for this particular cost price to be 3, but even if you insert more than 3 digits after the decimal, there is no problem. It will not throw error. It will accept it. But if it accepts, in what form does it accept? You see here, it has accepted these two values after rounding off. Because if you see here 1, 2, 3, 4, 5, 6, so since it can accept only 3 digits, so it is trying to round off. Now since 4 is less than 5, so it has left 1, 2, 3 itself. It has not incremented it. But if you look at the second example, when I have 1, 2, 3, 7, 8, so it can only accept up to 1, 2, 7. So what it is doing is, since this value is 8, so it is incrementing the previous value by 1. That means the 7 will be increased to 8. That is why you are seeing 1 to 8. So it is very much clear that if you are inserting more number of values than the defined scale value in your data type, then it will be rounded off. Now, what will happen if I insert decimal values for numeric 5? You remember we have created a column called as selling price, numeric 5. We have not defined any scale value. We have not defined scale value means we thought that we will never insert any decimal digits in this particular column. But now I am trying to do that. So let me execute this and show you the table. You see, still it is not accepting any digits after the decimal. What it is doing is, it is rounding it off to the integer part itself. And talking about the profit, of course, it is numeric. That means all values, I mean any number of, there is no limit before this and that. Of course, before decimal and after decimal. So that is why it can store any values, right? Now, okay, this we have already done. I'm sorry. So if you look at our numeric data type, so we have discussed all this, can store very large number of decimal values with exactness, right? In the previous data type, when we were talking about decimal, real, float 8, right? Double precisions, we have discussed that, you know, they cannot be stored with exactness because of rounding off nature, right? But here you can use numeric data type to store the values, to store the value with exactness. Calculation with numeric value yields exact result. Yes, this is also very, very important. That means suppose you multiply, let's say for example, cost price and selling price or profit. Suppose you want to calculate, let's say for example, you want to multiply these columns, cost price and profit column, right? So even if you multiply, you will notice that the result which you are getting is is an exact result after the decimals also, right? But that is not applicable for the other data types which we have seen, which is nothing but your float, double, and float and decimal, right? Because they will have a approximation value. Numeric p, which we have already discussed, is a positive precision. The scale 0 are positive, so this is equivalent to numeric p comma some value of precision comma 0. Numeric values of any length can be stored. So this is again any length we have discussed. Numeric values of any length can be stored here. Now, one more data type which we wanted to discuss about is serial. Now, before we jump into serial data type, let me give you a context of it. Serial data type is very much similar to integer data type. Serial data type is very much similar to integer data type. We have already seen that. We have already seen integer data type in our previous video, right? We have seen integer data type can be of 3 types, which is of small int, right? Then we have seen second type is an int, and the third one is big int, right? Third one is big int. In case you have not watched my previous video, you can go ahead and check them out. We have done a lot of practicals to understand this. Now, serial data type is very much similar to integer data type. Small ints corresponds to small serial, integer corresponds to serial, and big int corresponds to big serial. The only difference between small int and small serial is that it accepts positive values, whereas in small int you might remember that the range of small int was from minus 32,768 to 32,767, right? That means this is I'm talking about small int. I'm talking about small int. Sorry about my handwriting. This is small int, right? So it accepts negative numbers also. That means from minus 32,768, right? This is 68. Whereas serial will have only from values from 1 to 32,767, the same range. Same thing is for int, serial data type, which is accepting 4 bytes, which is equivalent to integer, which also stores, whose storage size is again 4 bytes, right? And you see the upper range is the same. The only difference is serial is accepting only positive numbers, whereas here serial is mentioned to be as positive numbers, which is similar to big int, right? Another difference is serial, whenever you define a column to have a serial data type, it means an auto increment feature is enabled. That means when I'm saying auto increment means what? Let's say, for example, I am defining a column as ID. Now, if I define this data type, let's say for this to be as serial, Now, what will happen is an auto increment feature will be enabled. Enabled means you do not have to insert the value for ID. So whenever you insert the first row, automatically the value will start from 1. If you insert the second row, the value of ID will be 2. If you are inserting the third row, the value of ID will be 3. Automatically, you don't have to do that. That is why it is called as auto increment. It increments the next value by 1. 3, if you are inserting the next row, automatically this value will be incremented by 1. It will be incremented by 1. That is why it is called as auto increment. In many places, you might have seen they use serial data type to define as a primary key, right? They will define a column, let's say ID, and then they will say serial data type, and then they will mark it as a primary key, right? Many places you would notice they do that, but it is not advisable. The reason is because serial data type definitely gives you an auto increment features, but it never says that these values would be unique. It will never say that these values are unique, right? That is why it is not advisable to use, you know, serial data type as primary key until unless you are very much sure. That's why I am telling you, serial data type, it definitely gives you a feature of auto increment, but it never gives you a guarantee that the value would be unique. I will explain that to you in detail. When does this duplicates, when do you start seeing duplicates value in serial data type? I will talk about all these things in detail. Now let us try to create a table and let's try to understand. So let me create another table called as serial table with 4 column called as small id, big id, and product name. So small id I have defined as a small serial data type, id I have defined as a serial data type, big id I have defined as a big serial data type, and I have created one more column called as product varchar 10. So of course we have not discussed the data type for character values, which we will do it in upcoming videos. For the timing, let me execute this query. Yes, this query has executed successfully, and let's look at the table. So you see here the value has been created. Now as I said, you would notice that here none of the columns are named as serial. None of the columns are named as serial. What is the name given? Small int, integer, and big int, right? You see here small serial, as I told you, small serial corresponds to small int, serial corresponds to int, and big serial corresponds to big int. That is why you will see here I have mentioned it is not a true data type but a notational convenience for creating unique identifier columns. Though I have written unique identifier columns, but this is not true in all scenarios. We will see in what scenarios it may not be, it may not have unique values, right? Now, since I have created this table, let us insert some values into it. So let me insert 4 rows. Now you would notice here that I am not inserting any value for small id column, and big id column, because I know for sure that this value will be auto incremented. That is why we have defined them to be as a serial data type. Now let me execute this piece of code. Now you see the value has been inserted A, B, C, D in my product name, and you would notice here that the values for small id, and id has been created 1 2 3 4 1 2 3 4, and that it has been auto incremented. The increment value is 1. That is what a serial data type means. Now what happens if I explicitly insert the value in these columns? So the first question is, can I really insert some value in serial data types? In previous example, I have not inserted any value in the serial data types, and I have mentioned you earlier, I have explained it to you earlier that you don't have to do it explicitly, because automatically SQL will understand and it will keep inserting the values, and as you keep inserting new rows, the previous row, the new row value will be incremented by 1 based on the previous row. That is what the meaning is, right? Now here I am explicitly trying to store the value. So first question, is it possible for us to store a value in a serial data type? Yes, of course it is. So let me execute it and explain it to you. So the moment I execute this, you'll say it says query returned successfully in 130 milliseconds. Now let me execute this and see the result. See, I'm getting 10 10 10, which I have inserted over here, right? I have inserted 10 10 10 for all this column, which is small id, and big id, which I'm able to see 10 10 10. Now the question is, what happens if I again insert few columns? So here you see I have inserted 1 2 3 4, right? And again I'm inserting these many rows, 1 2 3 4 5 6 rows I'm inserting. So now the question is, first question is, if I insert 6 rows now, definitely the data, the value which should be inserted in this column should be 5, 6, 7, 8, 9, 10, right? And again, these 6 rows when I'm inserting 10. 10 is already existing. So what will be the next value? Will the next value will be 11, 12, 13, 14, 15 and so on. So, or it will be 5, 6, 7, 8, 9 because till SQL has inserted only till 4. SQL has inserted only till 4 by itself, but the value 10 was inserted by the user. So what SQL is going to do? Is SQL going to continue the value from the 5th row, which is from 10? Will it insert 11, 12, 13, 14, 15? Or will it continue from 4, 5, 6? Now, if it inserts from 4, 5, 6, 7, 8, 9, then 10 is already there. So will it duplicate this 10 value or not? Now there are a lot of questions which we need to answer, right? Let me insert and solve this query, right? Now you will notice that it has incremented after 4. See, since 4 was the last value inserted by SQL, after that 10 was another value which was inserted by user. So after that, when I'm inserting new rows, SQL has ignored this row and it has started continuing creating the serial values from 4 itself. 5, 6, 7, 8, 9 and it has created 10 also. So 10 which I have inserted and this 10 is being inserted by the SQL. That means this 10 has been inserted by the user and this 10 has been inserted by the SQL. That is why I was trying to say that there is no guarantee that if you define a column as serial data type, it will always have unique values. You remember I have said it is generally used for creating unique identifiers. It is good for creating unique identifiers, but only if user do not explicitly insert value in the serial column. Only this is definitely creating unique identifiers because automatically it is incrementing the value by 1. Right, you see here it is incrementing the value by 1, but the uniqueness can only be retained if the user do not insert any values explicitly. The moment they do it, there is no guarantee that the uniqueness will be maintained because SQL will accept the value inserted by user also and it will continue inserting the value in its own fashion, right? Now, let me show you another example. Let me delete some value. Let's say I'm saying delete from serial table where small id is equal to 10. I'm deleting this value 10, right? I'm deleting this value 10. Let me execute this. And let me show you the table. Let me copy this. Let me copy this. Oh, it's already there. So let me execute this also. Right? Let me execute. So you see the 10 has been deleted. Now I am again inserting the value. Now the last value is 9. The last value is 9. Initially SQL has already inserted a serial value of 10 on its own, which I have deleted here. And now again I am trying to reinsert the value. Now what will happen? Is it going to create after 9, which is 10, or it is going to create after 10, which I have deleted? Let's check it out. My query has executed successfully and then I am executing it, right? You see here the value which I have deleted, right? That SQL does not care about, right? That it does not care about. It comes to 11, 12, 13, 14, 15, 16, right? So what is the nature of serial? See, the nature of serial, to understand all these complications, it is very simple. All you need to do is you need to understand the nature of serial. See, whenever you are inserting a serial values, right? SQL will remember the last value which it has inserted. SQL will always remember the last value it has inserted, right? And based on the last value which SQL has inserted, it will keep updating the values. It really does not care what value has been inserted by the user, what are the values which has been deleted by the user. It really does not care about. Now, one last thing which we wanted to see is, is it that serial value only accepts positive numbers, or can it also accept numbers, negative numbers? Say, let's say I am inserting here -5, right? And again I am inserting here -6. Again I am inserting here -7, right? And let's say this value is something, right? So you remember I have mentioned the range to be as 1 to 32,767 for serial number. That means a positive number. I have never said a range of negative numbers. Now, the moment I execute this, now see what I'm trying to do here. I am trying to insert negative values. So the question is, does serial data type, any serial data type, small n, small serial, serial or big serial, do they accept negative values? Let's see. Oh wow, see, the query has executed successfully, right? The query has executed successfully, right? Now the moment I execute this, you see negative value is there. You will notice that -5, -6, -7. So serial also accepts negative value. Always remember that. Serial data type also accepts negative value if the value is being explicitly inserted by user. If the value is explicitly inserted by user, then serial will also accept negative values. So I hope all these points are very much clear to you about the serial data type and the other data types which we have discussed, which is numeric, float, real, double precision, and everything. Right? Now, please practice all these things. I know this might be overwhelming, all this information might be overwhelming for you, but if you practice this on your own, this is really very simple. If you want to continue learning SQL or Python or data science, machine learning, artificial intelligence with me, please like and subscribe my channel. Also hit the bell icon to receive notifications for my upcoming videos. Thank you so much for your time and patience. You have a great day ahead. Thank you.